So yeah, this talk is making Alexa do your dirty work, improving your toolkit with serverless computing. So it's not anything as far as like a security audit of Lambda functions, serverless functionality in general. This is just how we as InfoSec practitioners could potentially use serverless computing, which is the new hot thing, as you've probably you've heard. How to use it to improve our daily lives, make it easier. Most of this will be focused on from a red team perspective, but I'm trying to throw in some insights, just what I would think might be useful from a blue team perspective as well, but at least something to maybe get you thinking about how you could use serverless computing. Come on now. So who am I? He's already kind of stole my fire there. Yeah, consultant in CC Group, red teaming, cackalacking the flag. Wah, wah, I know. All right, so here's the agenda where we're going over a brief introduction to what is serverless, if you haven't heard of it before, why we should care, how to get started, go through some use cases for red team, try to do some live demos. God, I don't know why I'm even like attempting to try this, but we'll see how it goes. I'll go over my short list of ideas for blue team and have a Q&A. So what is serverless? Despite the name, there are servers involved. So I don't know why they call it serverless, but basically what it is you don't have to worry about the servers anymore. You're just handling the code. So it's kind of like how, I mean, originally there was the monolithic large application. You had to deal with the server, every part of it. Then it was kind of broken down. We have the containerization to where you're just dealing with the app itself, but you still have the full code base. Serverless is just breaking that down one step further to where you are in charge of the runtime that's going to handle one specific part of ideally the entire like code base or the application, the workflow of the entire application. So functions, and I have that little Lambda symbol there. That's just kind of a popular way to summarize. Obviously, that's the Lambda symbol. I have that in the slide sometimes. So if you see that, that's what I'm referring to as a function. They're pretty much like little Docker containers that are short-lived. The amount of time. Sorry, I guess I should preface that with what I mean by short-lived is, so for example, in AWS Lambda, there's a max time limit, I think, of 15 minutes before the container will just die and delete everything that was in memory at the time. And there's some caveats to that. If it's like an HTTP-based Lambda function, it's only like 5 minutes, but each provider has their own rules. But essentially, yeah, these are like little Docker containers with the purpose of just doing one task, finishing it, and then being done. But then, if that doesn't really make sense, oops. Oh, forgot to move one thing. So another thing I want to mention, we're going to be talking a lot about the serverless framework. So if you've seen this logo before, try not to get confused with the two, but serverless is just the idea of like, all right, we're going to like really break down these functions into isolated little runtimes. The serverless framework is just one of the many frameworks out there. There's a bunch of different ones that basically abstract this even further to make it simpler for someone like me who's never done Lambda functions or anything, just make it a little bit easier to get started and manage deployment, packaging of all your code, updating your code, stuff like that. So why does this matter? Like, why would this ever be useful? It makes your deployment of code super fast, super easy to update. Again, you don't have to worry about a server. You don't have to worry about patching. That's on someone else's checklist for the day, someone at AWS or Google. What's really great is you only pay for what you use. And what I mean by that is literally you're only paying every time a request is made, every time an event happens. And we'll kind of go into a little more detail about that. But I like to compare it to, like, think about an S3 bucket. I know there is obviously some pricing for the persistent storage, but you're paid more by like how much it's actually being used. But that's what's really great about serverless, and that's across all the providers. You're only getting charged for what you use. Let's see. The next thing is the scalability part. It makes scalability super easy. Like, if I had to scale some application for 1 million users, I would just give up and quit because I'm not a great developer by any means. But the serverless, the way the whole platform works is that it's got that built in. So whether or not you have 5 users or 1 million users, it's just going to cost you more based on the users. For the most part, I mean, obviously it depends on the application you're designing, but you really don't have to worry nearly about scaling it out, or if you need to, it's going to be a lot simpler to implement in general. So before we move on, I did want to mention some previous work kind of in the serverless area. A friend of mine, you probably know his name, Ray Doyle, who's not here today, unfortunately, was probably the first I could find actually on anything that at the time wasn't called serverless. It was literally, he wrote a blog about making his Alexa device do a port scan using some Python scripts or whatever. At the time, the thought was like a Lambda skill can only run Python, like it's just a Python runtime. Some of the examples I want to show today is like you can literally run whatever you want to, as long as, again, kind of like I was saying, it's like a containerized EC2 instance. You can run any binary as long as the libraries are available. So like a static binary will run fine. So we'll be showing some like examples of using Nmap, even headless Chrome, stuff like that. So yeah, that was the first example I could find. The next one that's pretty recent, I think in the past year, is actually a really good resource. I forgot to show little pictures here, sorry. I don't know why it's not loading on my computer, but I'm controlling this from my phone. Yeah, there's his blog. Yeah, Rob Knopp is the next one. I just want to show this list here, because this is definitely, if there's any web pen testers out here, he's got a lot of very useful examples, specifically the one if you see over here, the Gopher redirect, or the server-side request forgery Slack notifier. Essentially, if you're doing a web pen test and you found, let's say, potentially an XXC, and you want to see if it'll go outbound, but it has to have a valid SSL. You don't want to spend the time, or maybe you don't already have that set up. It's really easy to set this stuff up with serverless functions. And he's got full source code, which that blog will have a link to it. And the next one, another one, more recent one that's more along the terms of red teaming, was from Dominic from NBSec, which is about making serverless web bugs. And what he means by web bugs, and I've kind of stolen that term too, is it's kind of like a honey token, but basically the purpose is for tracking either like a target opening up a phishing email, or a target opening up a website. Again, using these unique URLs that'll track who's opening what. He goes through an example that it's pretty good as far as how using it with Python. Mine's in the great language of JavaScript, so we'll get to see that here in a second. All right, moving on. So how do we get started? What I'm going to go through today, just real quickly. Actually, I don't know if the internet's going to work on here. Well, let's see. Essentially, all it really takes for the serverless framework is you do have to have Node.js installed. That doesn't mean you have to use Node.js for any of your skills. That's just to use the serverless framework. It does support, obviously, all the different runtimes. AWS, for instance, supports Golang, Python, even Ruby now, Node.js, a bunch of others. Yeah, this is just going to be using for installing the serverless framework. Let's see if I can. I might have to skip the installation demo here, but let's see. This isn't working as well as I thought. Yeah, no one wants to see installation anyways, but so it's npm install serverless, and at that point, all it really is you'll have your source code. So let's just say we already have that installed. I can't find my mouse over here. In this case, I'm using Node.js as my frame, the backend for the source code. What serverless is doing is the serverless file, it's a YAML file, configures all the options you want to send. It's basically going to take care of, like if I want to define, in this case, a DynamoDB database to set up that I want to store some data in, or set up an S3 bucket, instead of having to like manually go through the process of doing that, either through the AWS command line or go through the GUI, serverless can take care of that for you. Deploy it, delete it, update it, whatever you want it to do, all within an easy config file here. So here I'm just saying name AWS. I'm using, this is the provider. The runtime here is Node.js. Stage, the reason why you see this is typically you'd see stage as dev or prod or whatever, but this actually defines part of the URI path if you're making an HTTP service. So In this example, I'm trying to make something that looks like, there's like UTM trackers or whatever. So this is saying the stage is UTM is literally going to put that in, like it'll be execute.aws Amazon and whatever.com/UTM, then whatever else I define. So, and then here's just some other variables you can define custom variables for the environments. And what this is doing is going to do some crappy or ghetto encryption to make it try to obscure the fact that I'm tracking users, I guess is what the point is. So. Yeah, I know. If anyone took a screenshot of that, I'm screwed, right? So I took a bad choice by taking the wireless mic here. Let me get back to the slides then for now. Yeah, if you don't mind, if that's possible. Everything. Nope. Perfect. Whoa, check. Hot mic. All right. And let me. This is never going on the internet, right? Like everything I say here is off record, correct? I'm just kidding.
Well, ask Ray. Sometimes it won't show up.
He's blessed. Then he's very blessed. There we go. I just want to be able to see what I'm looking at. Okay, let's see. So just to save some time, but essentially once I had my code ready here, and this is just like any standard Node.js package, this could be a Python set of Python scripts. Once you're ready, you literally just run serverless deploy. And based on that serverless YAML file that I've configured, that takes care of everything. And up here you can see, once it finished, it has this is what the base URL looks like. Now, obviously, like from a blue team perspective, you could probably track them down on the execute-API. I mean, there's going to be legitimate usage of this, but if some red teams just consistently using this, that's probably not the best idea from a red team perspective. But my tip there would be to like maybe front this with CloudFront or any other type of redirector to make it a little more unique. But really, the purpose of this is just I literally, once I have written the code, I can spin this up, take it down, making modifications just so quickly, not have to worry about that like long-term management of the infrastructure. So let's see. I don't want to get off too far. So yeah, we skipped that demo kind of went off trail there a little bit, but so yeah, so I don't get too sidetracked. I want to make sure I do my things in correct order. So yeah, we're going to go over some common tasks now. These will be demos that will probably not work, but it's cool, right? Some common tasks that I've listed here from a red team perspective. One, performing active analysis against a target. So that would be maybe your pre-exploitation phase where we're trying to maybe do some in-map scans of the target environment. We're probing at a vulnerability, some service. We're not sure something's vulnerable, but we're probing at it. Stuff that a blue team could pick up if they're looking at it. Next one is just deploying redirectors. So whether it's for phishing or your command and control traffic, having multiple domains that are isolated from each other so that if one gets burned, you're not immediately going to burn the rest of your infrastructure. And then lastly, creating and testing payloads. There's always, at least for me personally in the past, I've had a couple of fails where maybe I leave behind my name in one of the payloads and leave in like the debug symbols, and then instantly like one of the blue team members, they're like, hey, it's red team, great. So, so for the first one, we're kind of going to segment it or go into the fails or examples of fails. So while performing active analysis, let's see. So in this case, this example, we're going to go with a shared VPN. So we have multiple red team operators analyzing a vulnerability against a target service. And unknowingly to them, they get detected by the blue team. So the blue team sees the activity, knows it's malicious. Whether or not they know it's red team, they decide not to like make themselves known. So they just kind of silently take note of what happened. Let's see. So then a week later, the red team mistakenly uses the same VPN connection from the same IP address to exploit that service. and the target's incident response team immediately detects it, shuts them down, ruins that the vulnerable service is then blocked off, because at that point they know, all right, they're definitely going after the service, and it pretty much burns that target. So obviously that's not something like a good red team would do, but I mean, we all make mistakes, so it can happen. The use case here, again, for the serverless, doing something like, hold on, what was this one? I think I didn't have a demo ready for this one, it's all good. But using serverless to, let's say, oh no, actually, no, sorry, I'm completely off. In this case, we'll just go with a running IMAP script and show how you could just do this to where it would look like it's coming from AWS, just some random, like one of the AWS IP addresses instead of the same VPN server you're using. So let's see. Make sure that's big enough to see. Don't worry about that message. All right. So in this case, I'm kind of still working on finalizing this. I know I've got a couple of these that I can actually share out the source code for that are somewhat working, but ideally I was working on kind of like a serverless kit to where you'd have all these different tools within one framework. So here when I'm running SLS kit nmap, it's instead of actually just straight up running nmap, it is, let me get there real quick. Basically running this Node.js script that then invokes a serverless function that I already have deployed. And that takes care of obviously performing the scan as well as whatever the results are. It saves that to an XML file, to an S3 bucket temporarily, downloads that to my clients, and then deletes everything. So it's a lot of moving pieces. And this is kind of like a convoluted example, but it's just kind of the point being, again, just to show you that like you can do some cool stuff with serverless computing. So in this case, I'm going to be scanning just an IP address that I own. Please don't take note of it and start scanning my website, but I'm sure Garrett, who's in the crowd somewhere, is going to do that, or he's already doing that. But so here you see initializing serverless nmap scan, and comes back and say, hey, this is port 80 open. You do the same thing, I mean, any type of scan. One thing that I found that's kind of limited to the serverless framework is there's no easy way to just say like, all right, I want to deploy this out to every region possible. That's not a feature that's supported yet. So right now I just have like a install script, just basically a bash loop that goes through and says serverless deploy to every region. And that within the script itself, it can tell how many regions you have deployed and then try to randomize that so that every time you're going to run nmap, it's going to be coming from a different IP address instead of just the same Lambda function. So that's the idea there. And just one more example on the scanning side, ported GoBuster as well. Make a prayer to the demo gods real quick. And so this is actually going to take a local word list that I have on my system, upload it to an S3 bucket. The remote Lambda function is going to then retrieve that, run it with GoBuster, save the results, and would in this case, it's just going to return to the standard out, but also has the capability to download the results as well. Okay, had a little error there, but you get the idea. It should work. I didn't pray long enough to the demo gods. So again, the point with this would be if you just were still performing that reconnaissance portion of engagement, and you didn't want to have to like, maybe someone else is doing something really low and slow, and you just want to like go all out, scan something, or do some dir busting, trying to kind of like segment things out. Serverless computing is a really good option in that case. All right. Yep, I definitely got that in the wrong order. Let's see. Sorry. All right. I'm going to skip ahead just for the sake of the time. I guess real quickly, I will mention the redirectors. So that one, I didn't have time to finish the sample code, but it's the same concept you've seen probably a lot in different blogs, using a simple web redirector, whether it's like hosted on Google App Engine or AWS or using CloudFront. You can do the same type of thing with serverless computing. It's just one more option that you have as a red teamer. So an example of doing that, I think I've got a screenshot in here, at least of the code. That's gonna be really hard to read, but just basically just deploying a really simple web server that just says, like, if the request is coming to the intended target, then forward it over to my C2 server and not actually expose like your long-term C2 server's host name. So that's the idea there. If you are a fan of Node.js, serverless framework supports Node.js, the Express framework, which is makes it really easy to make web apps, and it supports the proxying. So it's pretty similar to like Python's Bottle. I'm sure you've used that. So, all right, and then the other one, going through creating and testing payloads. So this one I've probably spent the most time on because it's definitely not like the intended functionality of serverless functions. But the scenario here would be the red team has a C# based toolkit. They maybe have got a short window for an engagement, and they're building out their toolkits and decided not to take the time to actually like obfuscate their payloads or recompile them or anything like that, which ultimately leads them to getting burned because the target just deployed some new EDR product that's made some easy detection based off a static string in one of their tools. So this is the solution to this, and there's other solutions to it as well, but using Azure. Azure also has functions that are Windows-based, at least the version 1, which I'll go into a little more detail, is basically using that to automate your obfuscation and your compilation of your payloads is what we're gonna go through now. So let's see. Yeah, so I just mentioned a second ago about the types of functions. They call it version 1, version 2. I'm not actually sure what version 2 is, other than that it only supports .NET Core. Version 1 is literally like it's a Windows 10 container that's got a full install of Windows 10 and full access to the .NET framework. So I think it's 4.7 all the way back to 2.0. So that means you get access to some of the command line utilities you'd commonly use in a pen test or red team engagement, like CSC, .exe, MS build, stuff like that. In this demo, it's an unfinished one, so it's a little rough around the edges, but again, it's kind of just to show you that it's possible. We're basically going to be using CSC remotely to compile a payload, then use ConfuserX to obfuscate the payload, and then you would want to retrieve that back. And ideally, you'd want that it would be awesome if you could do that. Like every time you're going to use this tool, just obfuscate it at different times. So every time it's getting used, it's going to look different from a blue team side. Let's see. I'm probably not logged into Azure. I just realized that. And dare I risk my credentials being exposed to you guys? Let's see. So I do have this. I think the easier way might be just to kind of do a quick example of if anyone takes a screenshot of this host name, I will take it down within the day because it's intentionally vulnerable. Let me show you. So I basically use this just to kind of enumerate what was available for me within an Azure function. So here you can see, like, literally, I just did running, well, actually, this part is just saying, like, read the contents of whatever folder I want to. C drive. For some reason, everything is mapped to the D drive, like everything that's actually useful within an Azure function. Let's see. So whenever you upload your function, it's the way Azure uses it. It's actually like the whole file system is its own blob storage, which is kind of like the same thing as a S3 bucket. And you can access that. Let's see. Let's go in here real quick. Here we're gonna just, I don't know if I can see that very well. Here you see it, you have everything within this .NET 4. And in the demo of compilation, let's see if I have anything in here. You know what, I think actually part of this will work. Let's see. Yeah. So the way this would work is, so like I was saying, this part's still very, very rough. Ideally, it'd be automated. You would first want to upload your payload, the CS file, to the remote blob storage, which that part's already done in this case. Then we would compile the CSC and then obfuscate it, then retrieve it back. So just a really early version of this I have is running node compile, which we should see the output. There's the output of CSC compiling the payload and then running node obfuscates. This is going to be running Confuser X. And there you see the output from that. And to get the content, right now we're just going to do this the extremely ghetto way. There you see the payload.exe just got obfuscated and stored there. Somehow I got signed out of Azure, so I would need to manually download that, but it's kind of out of the scope of this example anyways. But again, I know it's really rough around the edges, but the point of this is just kind of get your minds thinking about how you could potentially, there's probably a billion other better ways to use this stuff. But I mean, all of this is just, every time I run one of these commands, that's a function that's being spun up, it runs it, it goes away. Like it's, and the only part that's being persisted here is that storage in sorry, I almost said S3 bucket again, the blob storage for Azure's part, but the runtime, the environment is actually, I mean, it's temporary, it's going away the second that it returns this response you see here. So it's pretty fascinating stuff. Let's see what we have next. Before I get, oops, we lost that. And also did want to throw out, I know a lot of people were really hesitant about using like cloud services. There is, I mean, if there's still, you can use some of the benefits of serverless functionality and host it yourself. There's a project called OpenFast, like Open Function as a Service. If you want to deploy this within your own environments and but still offer it to your employees, your users, but not have them use a cloud service, you would still get the benefits of scalability, of probably cost savings from just not giving everyone a server instead you just be letting them run functions. So just wanted to throw that out there as an option. Some examples that I really wanted to get around to making but didn't have enough time was automating basic like document analysis using OLE tools. I mean, it's just a set of Python scripts, and that was like one of the first use cases for Lambda was running Python. So the idea would be similar to what we were just doing with the Azure one with the compiling payloads, but instead, maybe as part of your blue team workflow, whatever it is, however you get your data, wherever you put it, have a Lambda function that would analyze anything that you might think is suspicious, or just analyze everything, I don't know. Running OLE tools against all the Office documents that maybe contain macros, stuff like that. Another easy one to throw together would be using ClamAV, which is a free malware scanning that could be, so a lot of the stuff I tested like in a EC2 VM locally, so I was able to verify that I could get it to work. I just haven't had a chance to port it to an actual Lambda function. But so again, the idea would be to somehow throw in automated ClamAV scans into your blue team pipeline, stuff like that. And then another one, don't have a demo actually at the moment to use, but it's possible to use. I don't know if anyone here is familiar with the Puppeteer project. It's an API to control Chromium headless. Another idea would be to deploy that and use that whenever, let's say, you got all your emails coming in, you get some links, you detect a domain that's maybe it's a recent domain, haven't seen it before, and there's a URL in the domain. Instead of having like something internal make a request to it, or have even like an external service from the same IP address continually checking for that, you could use serverless functions to maybe pop up a Chromium instance, browse the website, see if it's automatically trying to download a file, do all that type of analysis and store that there. Yeah, one thing I want to throw out, like I know the earlier example we were talking about is like scanning from the same IP address. That's something that red teams can mess up from and get detected, but it also goes the other way around. As far as blue teams, I mean, sometimes blue teams get detected by the red team and the red team doesn't make that immediately obvious. But the example would be like scanning maybe or analyzing the analysis of a red team website or whatever. If that's coming from the same IP address with the same user agents, all those type of same heuristics you would use from the blue team side, the red team uses that as well. So that's how it kind of evens the playing field on both sides. If you implement something like this, just to like randomize where traffic's coming from, trying to randomize everything about what you do, I guess, really. And then lastly, which is similar to the web bug, I recently found this. There's actually a framework someone else came out with recently called Honey Lambda, which is just creating honey tokens using Lambda functions. So that'll be in here. I would highly recommend checking that out. I really haven't got a chance to dig into it too much, but it looks pretty sophisticated, and it looks like they spent a lot of time developing that. Let's see. And I think that's actually pretty much it. I think we ended a little bit early, but do you guys have any questions about serverless in general, or yeah?
So do you expect to run into cloud hosting provider in terms of service violation problems, or them clamping down automatically on your account and your servers?
Yeah, so I probably should have prefaced this in all with that. Technically, all this usage is within like the realm of like what they call it, at least AWS's within their use case policies, whatever. But yeah, you would need, if you were going to be using it, the pen test policy. Actually, I'm not sure because I know they just recently updated that. That might have changed, but yeah. So honestly, as long as you're using this against a target that you have the rights to scan with, Amazon doesn't really care. I mean, it's literally, we're not doing anything different by using InMap. It's not that much different than just making a standard web request with like curl, or I mean, obviously it's going to make more noise, but at the same time, I'm probably not going to try to spin up mass scan and scan the internet with it. I'm a little hesitant to try that one. I mean, there's probably a fine line somewhere, so I guess I would say just use your best judgment on it. But
so you haven't seen them have any automatic tools that might?
Oh no, but yeah. Then again, I haven't tried like large scans, but that would be an interesting idea, and that's in my mind one of the ideas. Like when I think of scalability, like that's something I would personally like to be able to do, is like set up my own project to scan. But like that's where you have to be like really good at actually coding to be able to scale out, like scanning the internet, unless you're just straight up running mass scan. But so yeah, that's nothing I've run into yet, but it's something to look out for sure. Oh, Jeff.
So when you're setting up a new like Lambda function, how often does the IP address of the outbound request change? I know in the past when I've screwed around with that, it seems like it always comes back from the same one if I'm in the same region.
Yeah, I think, I don't know off the top of my head, but if you're using the same region, I know they cycle it. It's less than every hour, I'm pretty sure. But yeah, there's not, by default, they don't, it would be nice if it just like would come from a different IP address each time. That's why I was trying to figure out a way to like automatically deploy the function to every region. So then at least you can randomize the region. But as far as IPs within the region, yeah, I think it's something under an hour. I can't remember off the top of my head, but yeah. And this is just for AWS. It's probably different for the other providers as well. So
you tried undeploying it, redeploying it with different names between scan over and over
to see if it
move it to a different real server.
No, actually I haven't tried that. The question was, have I tried deploying, undeploying, rescanning to see if it changes the IP address? I haven't tried that. I have a feeling that wouldn't make a difference, but it's definitely worth looking into. I mean, who knows? I'm not sure how they determine which IP address is being used, but any other questions? Otherwise, thank you everybody, and yep, I think that's it. Cool.